This is question number 2. In part A, for 3 marks, it says use the first fit bin packing algorithm to determine how the numbers listed above can be packed into bins of size 2. It's got 0.6, 1.5, 1.6, 0.2, 0.4, 0.5, 0.7, 0.1, 0.9 and 0.3. So we're trying to fit these into bins of size 2. So what I'm going to do is have bin number 1, bin number 2, bin number 3, bin number 4 and bin number 5. So let's start off. We can put 0.6 in the first bin. Now we go to the 1.5. Clearly if I try and put it in the first bin, that's going to be 2.1, which is going to be too big. Therefore we're going to have now 1.5 in the second bin. If we now look at 1.6, 1.6 won't go in the first, it won't go in the second, so it's got to go in the third. Now we got the 0.2, so I check the first bin and it can certainly go into the first bin. We're now on to 0.4. 0.4 can still fit into the first bin. We were only on 0.8, so we're now on 1.2. The 0.5 can also go in the first bin. So if we look at this now, we're up to 1.7. Now the next one I need to consider is 0.7. 0.7 can't go in the first, it can't go in the second, it can't go in the third, so we have to start a new bin. So 0.7 needs to go in the fourth bin. Here we're only up to 1.7, so 0.1 will happily go in the first bin. So 0.1 in the first bin. If I now look, 0.9 certainly can't go in the first bin, can't go in the second, can't go in the third, can go in the fourth. So 0.9 is in the fourth. If we look at 0.3, can't go in the first one, can go in the second one, so we'll place it in the second one. So 0.3 goes in the second bin. So 3 marks in total for applying the first fit bin packing algorithm. In part B, it says the list of numbers is to be sorted in descending order. Use a quick sort to obtain the sorted list. You must make your pivots clear. The question carries 4 marks. So what we're going to have now is our pivot. So I'm going to have a circle as the pivot, and then I'm going to say now that the square is locked in place. If you like, we can say locked or in the correct place. So let's go ahead and write these out. So we have now 0.6, we're going to have 1.5, we're going to have 1.6, we're going to have 0.2, we're going to have 0.4, 0.5, we got 0.7, 0.1, 0.9 and 0.3. If we look, we've got an even number of data items. So that means I locate the centre and move 1 to the right. So my first pivot is going to be the 0.5. What I now say to myself is I want all of the numbers that are larger than 0.5 to the left in the order that they appear, and all of the numbers smaller than 0.5 to the right in the order that they appear. So let's go ahead and do that. 0.6 is bigger, so we're going in descending order. So our largest number should be at the front, our smallest number should be at the back or the end. 1.5 certainly is, 1.6 certainly is, 0.2 isn't, 0.4 isn't, 0.7 is, 0.1 isn't, 0.9 is, so we put at 0.9, and 0.3 isn't. That means that I can now put the 0.5 here. We now consider to the right of 0.5 all the numbers in the list that are smaller in the order that they appear. So we're going to have 0.2, we're going to have 0.4, we're going to have 0.1, and we're going to have 0.3. I can now lock 0.5 in place. So all I'm going to do is say that that is locked in place. At this stage you could draw an arrow going to the end. I generally don't do it, but it is an option for you. We now find the pivot of these 2 sublists. So if we look at the first sublist, these are all the numbers greater than 0.5 in order, and we can see that we've got an odd set. Therefore I'm going to pick the middle number, which is for 1.6. So 1.6 becomes my pivot. Our sublist here, we've got an even number of data items, so we find the middle and move 1 to the right, and that gives me that 0.1 is my pivot. So let's start with the first sublist. We want all of the numbers now to the left of 1.6 that are larger in the order that they appear. 0.6 isn't, 1.5 isn't, 0.7 isn't, and 0.9 isn't. So we're going to have now the 1.6. So to the right, we're going to have 0.6. We're going to have 1.5. We're going to have 0.7. And we're going to have 0.9. These now are in order in terms of the 1.6. I've kept them in the order in which they appear. Now at this stage, we could just simply go down. I often just write it and put the box around. It's slightly more laborious. I think it just looks slightly easier to deal with. So what we end up with now is the sub list just here. We want all of the numbers to the left of 0.1 that are greater than 0.1 in the order that they appear. All the numbers that are smaller to the right in the order. So 0.2, that is going to be bigger. 0.4 is certainly bigger. 0.3 is, so we wind up with 0.1 just here. We can now go ahead and lock these in place. So the 1.6 is in place. We already know now that the 0.5 is in place, and now we can say that the 0.1 is also in place. At this stage, I need the pivots of the two sublists. This is the first sublist. We can see we've got an even number of items, therefore we go to the middle and 1 to the right. 0.7 becomes my pivot. This sublist has an odd one, so we just locate the middle, and 0.4 becomes my pivot. So straight off I can write down, again your 1.6 might have gone to the end at this stage, for 1.6. So we want all numbers greater than 0.7 in the order they appear to the left. So we're going to have 1.5. We're going to have 0.9. We will have 0.7 and we'll have 0.6. So I've just said to myself, which of these numbers is going to be greater than 0.7? The first one is 1.5, the second one is 0.9, and then we can write those down. We know 0.5 is locked down, and now we consider all of the numbers that are greater than 0.4 of this sublist. There aren't any, so I'm going to have 0.4. Now all the numbers smaller to the right in the order that they appear, 0.2, 0.3 and 0.1 is locked down. So let's just go ahead and put these on. And again, you might not have all of these locks in place. They might just be going to the end. That is perfectly fine. Different methods if you wish. So what we've got then, all of our locks are down. Our pivots from the last particular iteration become locked. So let's go ahead and put that on. And now we have 3 sublists to deal with. So here's the first sublist, there's the second one, which is quite nice, and there is the third one. So I now take this middle and move 1 to the right as we have an even number. The 0.6 chooses itself, and then again, even number 1 to the right. So the 0.3 becomes the pivot. So if we look at this, we know that 1.6 is locked down. I want now all of the numbers in this sublist that are greater than 0.9 to the left, which is going to be 1.5. And then all of the numbers, quite clearly, there aren't any. 0.9 is just here. 0.7 is locked down. 0.6 isn't going to be moving anywhere. 0.5, 0.4. I want now all of the numbers in this sublist greater than 0.3 to the left, smaller to the right. Nice little swap over. 0.3, 0.2, 0.1. So let's go ahead and just lock all of these in place, and we'll have the 1.6 definitely in place. We've got now the 0.9 definitely in place. We already knew that the 0.7 was definitely in place. We can now say that 0.6 is in the correct place. 0.5 is in the correct place. We knew 0.4 was in the correct place. We can now say that 0.3 is in the correct place, and we knew that 0.1 was in the correct place. Okay, finally, all we need to do is pick the pivots, and we can see quite clearly 1.5 and 0.2 are just going to end up locked down. So what we can do is give the final list, as there's quite clearly going to be no changes, and we've got now 1.6, we've got 1.5, we've got 0.9, we've got 0.7, we've got 0.6, and we've got 0.5, 0.4, 0.3, 0.2 and 0.1. This is now in order, so in order, and I can say therefore end of sort. So end of quick sort. So these are all locked down. If you want to put boxes around them, you're more than welcome to do so. So end of quick sort. So there we go. Again, with all of these D1 questions, when I'm doing them on here, it's going to be a lot easier and a lot quicker for you to do them. As you can see, we're already 10 minutes in to the question, and essentially I've only done 7 marks. I'm talking my way through them. When you do them, it should be a lot quicker. One thing, do check that this is just in order. So is it in order? Yes, it's in order. If you have made a mistake, just scrap it, go back to it. In part C, we need to apply the first fit decreasing bin packing algorithm to your ordered list to pack the numbers into bins of size 2. So this now is a first fit decreasing. Now, generally speaking, this should give us a better solution. It won't always be the case, especially in terms of what we're dealing with here, but often it will give you a better solution. So if you ever ask which is better, generally now first fit decreasing will give you a better or closer to the optimum solution. So let's set this up. I did the last one in 4 bins. I'm kind of expecting this will be 4 bins. So let's just put bin number 1, bin number 2, bin number 3, bin number 4. So we're going to have 1.6. 1.6 can fit in the first bin. 1.5 can't go in the first bin, so it's going in the second bin. 0.9 can't go in the first one, can't go in the second one, so it's going in the third one. Now 0.7 can't go in the first one, can't go in the second one. A common error here is that people put it in the fourth one. Talk your way through if you're unsure. Won't go in there because that'll bust it. That'll take us out to 2.3. That'll take us now to 2.2. This will take us to 1.6. So that's perfectly fine to go in there. So what we've got then is our 0.7. Now 0.6, if we look at what we've got, certainly won't go in the first one. It's not going to go in the second one. We're already up to 1.6, so we do need to start a new bin. Just be really careful because this it is open to lots of mistakes. Okay, let's take the 0.5. 0.5 cannot go in this one, but it can go in bin number 2. So that gives me up to 2. Now, I'm up to 2 on here. Remember, these are bin sizes of 2. So straight off, that's a full bin of 2. Okay, 0.4, that'll fit nicely in the first one. So I'm always checking, will it go in the first? Will it go in the second? Will it go in the third? And so on and so forth. So we're up to 2. If we now look at this one, now we've got 0.3. Now 0.3, we're only up to 1.6 here, so let's just get rid of that. Don't want to put the equals yet. I can put that in the third bin. Obviously can't put it in the first one, because if we're cutting these from lengths of wood that are 2 meters long, quite clearly I've got no wood left. So this one is going to be 0. What's that going to give us for 0.3? Okay, so that one's done. Now, already on here, we're up to 1.9, so I can't put 0.2 in. I know the first 2 bins are full, so it's got to go in this one right here, 0.2. I can fit the 0.1 in this one, which is going to tidy it up quite nicely, 0.1, and that will give me 2. And then we've got now, at the end, 0.8. So that's that part done. So all we've done is use now the first fit decreasing bin packing algorithm based on our quick sort to do that. Okay, determine in part D for 1 mark whether your answer to C uses a minimum number of bins. You must justify your answer. Okay, the lower bound, what we have now is the lower bound is the total length or weight of all of these numbers divided now by the bin size. So if we look at this, I can see, I'm pretty confident this is right. We can say that the lower bound is going to be 2 plus 2 plus 0.8, which is going to give me 6.8, divided now by the bin size. If you want to just check, go ahead, 2.1, 3.7, 3.9, 4.3, 4.8, 5.5, 5.6, then we're going to have 6.5, 6.8. So what I've done here is correct. So this gives me the lower bound, and I'm just going to calculate that. Won't need a calculator, will we? That's going to give me 3.4. So we round up to the next integer, because quite clearly we can't have 3.4 bins. We couldn't have 3.4 lengths of wood if we were buying them as wholes. So we'd say, therefore, lower bound is 4 bins. So lower bound is 4 bins, and we can say answer to part C. So answer to part C is going to be essentially the lower bound, and what we asked to do. So yeah, so part C uses a minimum number. So make sure you're answering this, uses the min number. So that is all we need to do. Need to show the lower bound. In fact, the first bit did as well. But again, you might think about in terms of the waste. So if we look at this one, if we were cutting these from lengths of wood, you could argue, well, that's going to be 1.8, that's 1.8, that's 1.6, and that's 1.6. So whilst this isn't part of the question, if we look at bin number 1, what we've got here now is the following. We've got in total there, what's that, 1.8? Bin number 2, we've got 1.8. Bin number 3 is going to be 1.6, and bin number 4 is going to be 1.6 as well. So you can see often, you know, this is why the first fit decreasing it is going to give us a better solution, because it might come somewhere down the line that we're wasting so much of each part of this that we'd need to get an extra length of wood or something to do that. So there we go. Again, 16-minute video, 11 marks. Generally speaking, you should really be shooting for a mark a minute, generally speaking. So with me talking, it increases the time, etc., etc., and with all the workings, but hopefully that has allowed you to see how you can do the bin packing and the quick sort algorithms.